We just talked about how you can find the molar mass of a compound by adding up all of the molar masses on the periodic table. Okay, and so now what we can do is remember, for example, like in the compound CH4, the molar mass of that, as you look at carbon, you look at the hydrogen, there's 4 of them, and that adds up to 16. And remember, that's 16 grams per mole. Okay, and again, let's go back to the whole dozen thing. That's like 16 grams per dozen. That means every dozen weighs 16 grams. Okay, but remember, a mole isn't a dozen. A mole is 6.02 times 10 to the 23rd. So that means that if you have 6.02 times 10 to the 23rd CH4 molecules, and you were able to weigh those, you would get a mass of 16 grams. Okay, and so the conversion is that 1 mole equals 16 grams of, in this case, CH4. Okay, so we can use that conversion. We can use those 16 grams per mole, or whatever the molar mass happens to be, to convert between grams and moles. Just like what we did earlier when we converted between the number of oranges and a dozen, we can do the same thing here with grams and moles. Let me show you an example of this. Okay, it says calculate the number of moles of glucose. So we're calculating the moles of glucose, which is C6H12O6, in 5.380 grams of glucose. So they're giving us grams, and we have to find moles. Okay, and again, what's the conversion that we have that involves grams and moles is the molar mass. So we have to go to the periodic table, and we have to find the molar mass of glucose. Well, we already did it earlier, and plus you can see it's right here as well. So what we do is we start with our 5.380 grams of glucose, and then we put the molar mass on the bottom. Now again, why do we do it that way? Remember, it's 180 grams per mole. Okay, and that when we say per mole, that's like saying 180 miles per hour. Well, how many hours is that? That's just 1 hour. Okay, so in this case, how many moles is it? It's 180 grams in 1 mole. So since we have grams up here on the top, we have to put grams here on the bottom so that grams will cancel. Okay, so again, there should never ever be any question, well, I don't know if I put the molar mass on the top or on the bottom of the fraction. It all depends on what you're starting with here. If you're starting with grams, then grams have to go on the bottom here. So then, what goes on top? Well, whatever 180 grams is equal to, which is 1 mole. And now we just go to our calculator. We take 5.380 grams, and we divide by 180 grams, and then you should, check your calculator, but you should get an answer very close to 0.02989. And again, notice there are 4 digits here, so I put 4 digits in my answer. That first 0 doesn't count. Okay, so notice here that to convert from grams to moles, you must divide by the molar mass, right? That's what we did here. We divided by that molar mass. Now, if we're going to do the opposite, let's look at example 3. It says calculate the mass in grams of 0.433 moles of strontium phosphate. So this time, notice that we're not starting with grams, we're starting with moles. So when you're starting with moles, what has to go on the bottom of the fraction? Of course, moles. Okay, and the reason for that is certainly so that moles will cancel. So the molar mass of strontium phosphate has to go on the top. I already did it. It's 452.8 grams. And now I go to my calculator. And since the grams are on the top this time, instead of dividing, we're going to multiply. So to convert from moles back to grams, you multiply by the molar mass. Oh, so you're either just dividing or multiplying? Yes, that's exactly right. But you got to do it right. If you're supposed to multiply and you divide, of course you're going to have it wrong. Okay, example number 4 says determine the number of moles of CuCO3 present in 85.9 grams. So in this case, we're starting with 85.9 grams of CuCO3. And now we know that grams, because grams are up here, we know that grams have to go on the bottom. So now is where I need to stop. I need to go to my periodic table, and I need to figure out the mass, the molar mass of CuCO3. How many grams are in a mole of calcium, or sorry, not calcium, of copper to carbonate? So copper is 63.5, so I'm going to put that into my calculator, 63.5, plus carbon, which is 12.0, plus oxygen, which is 16 times 3 is 48. So I have 63.5 plus 12 plus 48, and that is equal to 123.5 grams, again, per mole. So where do those numbers go? Well, again, because I had grams here, I have to have grams on the bottom. So what's the number that goes with grams is the 123.5. And what's that equal to? 1 mole. And so now I'm going to take 85.9 and I'm going to divide by 123.5, and I get a final answer of 0.696. I rounded that last number up because the next number after it was 5 or greater. So 0.696 moles of copper to carbonate. Okay? And that is all you've got to do there. So I'm converting grams to moles. So just like it says earlier, when you convert from grams to moles, what did I do? I divided by the molar mass of the compound. Okay, and then our last example, example number 5 here. How many grams of dinitrogen tetroxide are there in 4.38 moles of it? So again, we're starting with 4.38 moles of N2O4. And now before I continue, I'm going to make my little conversion area, but now I've got to figure out the molar mass of N2O4. So nitrogen's 14, there's 2 of them, so that's 28. Oxygen 16, there's 4 of them, that's 64. So that is 92 grams per mole. So again, I've got moles here, so I've got to put moles on the bottom. So 1 mole on the bottom, 92 grams on the top. Just like here, the grams and the gram cancel, the moles and the moles are going to cancel. So now I'm simply going to take 4.38, and I'm going to multiply by 92. And again, this has 3 digits, so my answer is going to have 3 digits, 403 grams of N2O4. So every time you either are converting from grams to moles or moles back to grams, you use the molar mass. Okay, you go to the periodic table just like I did on those 4 examples. You go to the periodic table, you find the molar mass of whatever compound it is, you add up all those masses, and then if you're converting from grams to moles, you divide by the molar mass. If you're going from moles to grams, like example 5, I multiplied by the molar mass.